Hey everyone, welcome back to another Simply ED video. Now, as highly requested, I'm going to make this video about the ACT science section. So, let's get started. Here you see the video overview, and what you're going to notice is that, kind of similar to my reading video, there's not really a lot of content that I'm covering. And that's because the test itself, at least the science section, doesn't have a lot of content, right? They don't really need you to know like specific concepts in bio, chem, physics, or whatever. I mean, they might want you to know like a little bit of stuff and maybe a bit of basic math, but not too much that I need to actually go over and cover it all here. Instead, it's mostly just about like being able to analyze graphs and read information and be able to like process that and answer the questions based off of that. So first I'm going to talk about my prep, then general strategies, meaning testing strategies, and then strategies for multiple perspective passages, and then strategies for graph or table passages. And at the end of this video, I'm going to do a walkthrough of two passages. So to start off, I'm going to do my prep. Now, I took this test back during February of my sophomore year, and I got a 36 on all the sections. Of course, that includes the science section. And for it, the ACT, I fortunately had a full week of school off right before the administration due to inclement weather. And so I just took a practice test like 9 days straight for every single day of that week. And that's how I was able to really get good and develop a lot of the strategies that I'm going to talk about in this video. I guess in terms of my science course load, although this really doesn't matter, I had already taken AP Bio and Honors Chemistry before my ACT was taken. And really, I just feel like for me, taking all those practice tests is what was really important to me getting the scores I got. Because ultimately, one thing I noticed is that for science, as well as reading it, really the whole test, timing is a problem. And so by doing a lot of practice, I got used to the timing and was able to develop all these strategies you're going to see in this video to overcome those difficulties. So, for general strategies, first thing is to do the easiest passage first. Now, what I noticed from all the practice tests that I did, as well as from talking to a few other people, usually the first passage is always the one that we're the slowest on. And so, what that means is, let's say normally like I do a passage at some certain rate, like let's say one question per minute. Maybe it takes me like it takes me 1.2 minutes to do a question on my first passage. So what that means for this is that I'm going to want to do all my easiest passages, the shortest ones first, because like 7 times 1.2 is 8.4, but then 8 times 1.2 is 9.6, meaning if it's going to be a slower, like going to take me a longer amount of time to do it, I should do the shortest ones first so that that longer effect has less of an overall like effect, right? Now, next is the multiple perspective passages. And for this, it's important to read the intro paragraph, which talks about like what the perspectives are going to be talking about, and then the first paragraph very thoroughly. After that, you want to highlight the differences and like what each perspective is really trying to say, like what their claim is, and actually try your best to take a note down next to it. It's really easy, like when you're taking this test on paper, because you can just write it like that. Because then when you're looking back to it, you can just quickly see like, okay, perspective 1 was talking about like X, but then perspective 2 was talking about not X, but Y. And you can easily understand, like, going back to reference it for a question, just saying, okay, this is what they mean. Next is the graph and table passages, and for these, read the first paragraph thoroughly, because again, this talks about like the overall subject matter, and then read the axes and the titles of each graph. That way, when you're going through each question, you can tell like, okay, this question is referencing like the first graph or the first table, and that makes it a lot easier to answer the question and be able to do them quickly. And similarly, make sure to skim the other paragraphs and procedures. Reason being is that like if you try your best to read it all and like memorize it all immediately, it's going to take you way too long. Instead, just go, and when you like, that's the point of actually reading the axes, right? So let's say like the first graph is like referencing the first body paragraph, right? Then you read the question, you realize that it's referencing the stuff you see in the first graph. Then and only then do you actually read that first body paragraph, instead of having to try to remember it all in your head, because you're probably going to mix it up. And now finally is guessing, and these are all kind of just typical strategies, right? First is to not linger. Like just trust the answer that you picked. You probably are right. Don't like keep looking back over and over again, because that's where you're going to lose time. Similarly, like I have this thing called counting. There's 40 questions, right? And so you want there to be like an equal amount of every answer choice on the test. right? So let's say like you currently haven't picked a lot of A's, but you picked a lot of like the other choices. Then if you really don't know what to pick at all, just pick A and move on. Try to make it even because it should be, now, not a guarantee. I wouldn't recommend doing this always, only if you're really unsure. But it should be a relatively like similar amount of all answer choices across the section and really the test. And then finally is just a very, very typical thing your teachers might tell you is to don't pick any extreme choices. Don't pick anything that might be true but it's not stated in the paragraph or the section they're talking about. And if it's partially true but not fully true, or it's like it doesn't answer the question but it is true, then yeah, don't pick that either. Right? Those are all kind of just standard test taking strategies. So now I'm going to do a live walkthrough of two ACT science passages. The first is going to be a multiple perspective passage, and the second one is going to be a table passage. This test comes from the Preparing for the ACT 2023-2024 PDF. So if you want, then just type that into Google and you can download the same test. Now, there are 6 science passages on this test for 35 minutes, meaning that on average there's 6 minutes per passage, so I'm going to give myself 12 minutes. Let's get started. So, in a particular playa, evidence shows that some large rocks have been moved along the surface, so... Okay, basically this means that the 3 passages are all going to be talking about the trails left by some rocks that are moving in the playa. Great. So here's our claim for all 3 of them. And notice, this is the way it's usually going to be. You don't need to read all this stuff initially for any of the scientists. What you're going to see is that usually these passages are always formatted in this way. The final line of each scientist is going to be their claim. So you know what, I'm not going to go ahead and read all this. I might read that later when the questions finally ask me about those scientists. For now, just by looking at these 3, I can tell scientist 1 is saying that the rocks are moving a lot in a few days because of ice, mud, and light winds. Scientist 2 is saying that they move a lot in a few hours because of mud, algae, and strong winds. And scientist 3 is saying that they move a little bit over a long time due to tectonic plate and strong winds. So, according to scientist 2, friction between the rocks and clay is reduced by which of the following? Okay, so for this question I do have to read what scientist 2 says. Okay, so the presence of mud and algae reduces friction between the rocks and the clay. That means the answer is D, mud and algae. Suppose a researcher observed that wind speeds are greater than 80 miles per hour needed to move rocks and playa. The observation is consistent with the following scientists' explanations. So 80 miles per hour, I think we can consider that to be strong winds. I mean, I know I would. So between these 3 scientists, like winds, strong winds, strong winds. Okay, so that means the answer has to be scientists 2 and 3 because those are the 2 scientists that are specifically mentioning strong winds. And the reason else they say greater than 80 winds are needed, meaning that they probably, let's say, at 40 miles. Okay, let's do a lighter number, 10 miles per hour. If we were to consider that to be a light wind, then that'd be fine, right? But they're saying you need to have a strong wind, so that's why this is only applicable to scientists 2 and 3. H. Suppose that no seismic activities are recorded. This would weaken which the scientists. So this one says ice, mud, light wind. This one says mud, algae, strong wind. This one says tectonic plate and strong wind. The answer has to be scientist 3 because seismic activity is talking about like tectonic plates and earthquakes and all that sort of stuff. And scientist 3 is the only one that's mentioning anything like that. Suppose we discovered that a particular rock formed a 200-meter long trail in 72 hours. Would this support their explanation? Well, if you remember, scientist 1 is saying that they move several hundred meters in a few days, which several hundred meters in a few days, 72 hours. So yes, okay, this one says few hours. So the answer should be G because it says yes, and it's actually factually like it agrees with what scientist 1 says. Suppose that during 1 year, there's no measurable movement of any rocks from the playa during the spring. 1 and 2 would both agree that this was the absence of which factor. So basically what they're really asking is, which factor do both scientists 1 and 2 agree on? 1 says ice, mud, light winds, and then 2 says mud, algae, strong winds. So both of them are mentioning mud. But wait, that is not an answer choice. So let's go back and read, let's say this one. Spring, snowmelt. Runs on the playa. At night, cold temperatures cause the water to freeze. When they rise again, the ice melts, leaving a layer of mud on the surface. So, scientist once says that mud is forming because the ice, in other words, the snow, starts to melt. Therefore, the answer should be B. Air temperature varies between 4 and 47. Okay. However, this temperature does not get cold enough for ice to form. So yeah, that means the answer should be yes, because 4 degrees is indeed too high for ice to form. So it should be F, because that is literally what scientist 2 is saying in the second sentence. Based on scientist 1's explanation, a rock trail that is 33 centimeters wide is most likely made by a rock with approximately what width? So if you read the sentence, okay, so scientist 1 says that the trail width is only 2/3 as wide as the actual rock. My bad. Okay, if 33 centimeters is 2/3 of the actual trail, then you have to do 33 times 3 over 2 to find the rock's real width. 33 times 3 over 2, that's 99 over 2, which is basically 100 over 2, and 100 over 2 is 50, so the answer should be C. Let's move on. Actually, before I move on, I do want to point something out here. Notice, I really didn't have to read Scientist 3 at all, right? And even though I did read 1 and 2, I was mostly scanning it when the questions asked me for their information. I really don't need to understand the science behind what any scientist is saying that seriously. Just by taking the test properly and using these strategies, we can easily optimize and just dash through the test. When certain substances, CO2 is produced during foam. Okay, so it means these experiments are testing the release of CO2 gas from adding stuff to Diet Cola. Okay, so trial substance, volume, mass, trial temperature, volume, mass. Okay, so it looks like in trial 1 they're looking at different substances, and trial 2 they're looking at different temperatures. If another trial had been added in experiment 2, and then 450 mils have been, okay. So over here we see that the temperature increases and the volume decreases. So if I keep decreasing the volume to 450 milliliters, the temperature probably has to increase. So it should be J, greater than 60. Suppose the trial 6 had been repeated, but the bottle of Diet Cola had been left open and then undisturbed for 25 Celsius for 12 hours before it was attached to the apparatus. Would the mass of CO2 produced in this be greater or less than 0.969? Well, if you leave it open, right, then all like the bubbles, the carbonation is going to release from the soda, right? So I can imagine that like once you attach it to the apparatus, put that little tube there, there's not going to be as much CO2 left to collect, right? And as a result, the experiment probably is going to collect less CO2, so the mass should be less. So let's see which answer choices says that. Shouldn't be greater, so less concentration would have decreased. Yeah, the answer is C, because again, over those 12 hours, there's going to be less CO2 because it's all getting released into the air around you. So now the mass that you can collect is going to be less because there's less left to collect. 1 millimole of CO2 is a mass of 0.044 grams. How many trials total the production of at least 1 millimole? Well, let's see. Okay, it looks like every trial was a lot more than 0.044 grams, so the answer should be 8. According to figure 1, which of tube A and tube B, if either, had at least one end submerged in a liquid before the clamp is removed? Well, it doesn't look like tube A has an end submerged in either liquid, but tube B does, right there. So the answer should be tube B only. Is a relationship between the volume of liquid and cylinder at the end experiment and the mass of CO2 produced a direct or inverse relationship? Well, if I see here, as my volume is decreasing, my mass is also decreasing. Okay, so we have a direct relationship. So between F and G, as the volume of liquid increased, the measure of the mass of CO2 produced was increased. Well, yes, as my volume increased, my mass increased. So the answer should be F. That's a direct relationship. Consider these steps that are performed in each trial. According to the procedure, which steps these steps are performed in what sequence? Well, okay. Doesn't look like any of these were steps. A certain solid substance was inserted into the other end of tube A. Okay, so a solid was put into tube A. Okay, that's step 3. And the substance was secured by a clamp and then attached to a freshly the substance was secured. Tube, okay, that's not a step. Tube A was attached to a freshly opened bottle containing cola. So, yeah, step 4. And, okay, it doesn't look like, okay, I mean, I might as well go back and look. Clamp is removed, so that's step 1. So, yeah, 3, 4, 1, I don't need to look at the rest. The answer choice has to be B. Assume that the room temperature is 25 Celsius. And how many trials was the dye-cola tested at a temperature lower than room? Well, here, okay, these are all at 3 degrees Celsius. That means all 4 of these are lower than room temperature. And then here, trial 5 was lower than room temperature. So the answer should be 5 because it's 4 plus 1. So that's going to be it for my walkthrough. But I do want to stop us here. Take a notice. I don't really know what happened in this experiment. I don't really understand the apparatus, and I don't need to. Just notice that by taking this test, by using all these strategies, we're able to get around that. Get around taking the time to actually read all this thoroughly and understand it. And instead, we can just get through all these questions quickly. In fact, I had 2 minutes and 37 seconds remaining up to finishing. And that's including me doing another talk like this right after the previous passage. So, just by using all the strategies I talked about in this video, you can very easily get all the questions correct without really needing to think too hard and understand too deeply what's going on. And you'll still be able to finish well within the time range. So anyway, that's going to be it for this video. Please make sure to like, share, subscribe, and leave a comment down below. Also, if you have any questions, then you can either email them to me at simplymathNJN@gmail.com, DM me on Instagram, or use whatever media or social media I talk about in the description. Thanks for watching.